Hello, Math 126 students. This question 7, number 6, is one that got asked a lot in office hours. I'm going to use this as an opportunity to review pumping and work in general. So I'm going to do a good chunk of the problem, and then I'm going to end. I made a separate video about approximating, and with some approximating notes. But mainly I just wanted to use this as an opportunity to review, since I've been getting so many questions. So they give you this region. It's between 0 and 1. It's bounded on top, and then it's rotated. That gives you a tank. Some sort of tank that maybe looks like this. They say that it's filled with the liquid and then it's pumped to the top. So just a reminder, this is what I call a stack of books problem. That what we're really going to do is we're going to consider, if I took water from here and pumped it up, and then if I compared that with water that's up here, that started here, and I pump it up, and then I'm going to also talk about water that's up here and gets pumped to the top. Now there's a difference for each one of those, a difference in terms of how far it was lifted and how much it weighs. But what they all have in common is they all look like a disc. And so our job is to say, for any one of these, what's the pattern for the force or the weight? It's just another way to say weight. And the distance lifted. That's why I called these a stack of books problem, because we sort of are going to figure out, well, how hard is it to lift one book to the top? And then we're going to add those things up. So when the problem is all said and done, this is just a general review. We're trying to find a pattern for force times distance. Now in these questions, it's usually easier to write distance first, as I'll show you. It just looks better to me. But we're doing force times distance. And if we can figure out that pattern, and if there's a delta x or a delta y somewhere in there, then we can write it as an integral. That was the point of this section. Okay, so I want to figure out what the following two things are. So one thing I need to figure out is, for example, if I started here and pumped it to the top, I need to figure out that distance. And then separately, I need to figure out the force right there. And if I started here, I need to figure out this distance. And separately, I need to figure out the force there. So those are the two things I'm trying to find. Instead of doing it for every single one individually, I'm going to try to find a pattern. So you have to do this in terms of y, because if you take water at different heights, it gets pumped at different amounts. So we need to consider all the water that's at the same height. So let's say given a y here, that's step 1. Now the moment I label this y, I know that I need everything in terms of y. So there's a couple little things right away we could do, which is we could say x equals tangent of y. We've played that game before and labeled our graph. That is tangent of y. It also would be helpful to know when y starts and ends. Well, y starts at 0 and it ends here. So you can say when x is 1, that's pi over 4. So the truth is I already know several things. This is 0 to pi over 4. This is dy. But now the work that I need to do is to figure out how much water at a given height in a given thickness, how far is it going to be lifted, what's the distance lifted, and how much does it weigh. In these questions, in stack of books questions, the distance lifted is typically the top. It depends on how you labeled it, but it's typically the top minus y. In leaky bucket problems, the distance is delta x or delta y. That's why I like to separate these two ideas, as we talked about in class. So that's our distance, and that's what's going to go here. If you broke this up into a whole bunch of subdivisions, this might be y sub 1, maybe this is y sub 6, I don't know, however many subdivisions you've broken up. The distance is going to be pi over 4 minus whatever y you're at. And that means the distance is going to be this. Usually that's the part people forget, but you have to identify that right from the beginning, but that's what's going to happen. So then you get this natural question is, well, how is the dy going to appear? We're going to find that out in just a second. So the next job is to figure out how much this weighs. Now, there's a separate question I encountered in office hours that I wasn't really thinking of. So I'm going to come down here for a moment and talk about this. Because a few students were saying, I don't understand why you're multiplying. So before I do that, this is just a side question. This is not part of the same problem. But I'm going to give you a little box that's 2 by 3 by 5. So the volume of this box is 30. I'm doing this on the fly. So let's say it's all in feet. If I told you that there was a liquid filling that box, and the liquid was, what do I want to say? Let's say the liquid was 50 pounds per cubic feet. We call that density or force density. How much does it weigh? You'd multiply these two numbers together. So I realized that some students were just confused by that concept. If someone tells you something's full of a liquid that's 50 pounds per cubic feet, and it's 30 cubic feet, you'd multiply them together and say 1,500 pounds. Hope that makes sense. So if you're trying to figure out the weight of this, you first need to know how heavy the liquid is. And the liquid is water, which is 1,000 kilograms. Unfortunately, that's not force. It's mass. You have to multiply by 9.8. Pounds is already a force, but so you're going to have a 9,800. That's 9.8 times 100. That's the newtons per cubic feet. That's like this number. What we need to do now is figure out how much volume there is. Now, it's not a nice box. It's this disk. And the height is not 2. The height is delta y. So what you're trying to do is force times the volume of your slice. And now we finally boiled it down to something that looks kind of familiar. It's a disk. So we're going to find the area on top. It's pi times this. And if you've done enough of these problems, you know already that all was going to happen. So here the dy actually does mean the thickness of my slice. And so then we're down to just one last thing, which is what's the pattern for the radius? It's changing, and we've already labeled it. It's tangent of y. So a lot of the confusion people are having is just a mixture of confusion about things we did earlier in the term. Again, the approximation part is not something you think about till the very end. And again, the force is going to be 9,800 times pi times tangent of y squared delta y. So this again represents the volume of this. This is the weight per volume. Done. So we're just doing force times distance, and then we'd like to add all those up, and that's what this does. Okay, so there's the review. Now let's switch. This is a terrible computation, but in practice, if you're using Simpson's rule or any of these rules to do a computation, it's probably going to be messy. So this is going to be pi over 4 minus y tangent of y squared dy. So now is when you engage your approximation muscles. This is like your function. This is like my f of y. And that's what I'm going to be plugging into. That's my integrand. I pulled these numbers out to make things nicer. And if we're using Simpson's rule, it's going to be 9,800 pi over 3. Then you're going to have delta x. And you have to go, what is delta x? Oh, 6 subdivisions. So you do delta x is pi over 4 minus 0 over 6. That's pi over 24. And that's going to be, you plug in your tick marks. It's going to be 0. Simpson's rule says then you're going to have a 4. You're going to add pi over 24. So this is the stuff we've talked about as the quick way to do tick marks from earlier in the term. You just keep adding the width. That's going to be 2 over 24. Then it's going to be 3 over 24. And that's it. 2 pi over 24 plus 4 of 3 pi over 24 plus 2. And you could type these in as you went. Yes, that part's tedious. This is one of the more tedious problems. 4 of 5 pi over 24. So I thought I would also add this little supplement of What if you wanted to be a little faster? This is not really for this course because that's really for a future course. But if you wanted to do this, a low-tech way would be to just open an Excel spreadsheet. Now, some people have more experience with Excel than others. I know that sometimes when I do this with my TAs, they're really excited because Excel is helpful. It makes a lot of these questions, a lot of computations in general, easier. So if I was doing this problem in Excel, what I might do, and I know people are using other devices, I just wanted to give students that aren't doing that, just sort of give you the freedom to try this. I probably would do the tick marks. So I'm making notes here just for myself. So I would do 0, and then I would do plus. Okay, resuming my video, I had to look something up on Excel. So anyways, if I was typing in the tick marks, I would do 0. I would do equals the previous answer plus. If you've never used Excel, it takes a little bit of practice. But once you can do it, it is really helpful for a lot of things. So I'm just going to give all the tick marks. So I'm going to do pi. I had to look up how to type this in. It's like a function. I can't remember what the other, I think it's number of digits divided by 24. So that adds pi over 24 to the previous one. And then you want to add pi over 4 to the previous one. If you've never used Excel, it's really good at this. Now I went too far because we were only going to do 6. If I was doing this, I probably would do a quick check. Is this the same as pi over 4? Let me try this. Pi over 4. No. This plus this plus this. Oh, it's because that's not the 6 tick mark. So the tick marks are this. Let me do a little housekeeping here so you can see what I'm doing. This is x sub 0, this is x sub 1, this is x sub 2, this is x sub 3, this is x sub 4, this is x5, this is x6. So you start to go, well, how is this going to be any faster? Well, now you can just compute the function. So you can type in the function once, which is pi divided by 4 minus this value. I should have said y. And then you're going to do, and again, this is not going to be for everybody, tangent of this value to the second. And I should have, and that's it. So we have that value, and that'll give, so now you've done it just once, and you can just do it for the next tick mark. Add all these together. And now you have all the values. Now I have f of 0, f of pi over 24. I have all of these values now in my table. So what I mean is this value, sorry, I need to shrink that a little bit. So this value right here. So f of 0 makes sense. When you plug in 0, you get 0. This is just more for your information of how someone could compute this. There's other ways to do this too, but if you needed some help and some organization, and maybe if you're just interested in Excel, that's this value right there. And you could check the values. Maybe do a couple in your calculator. Once you're confident you have all the values, then you can do the calculation. Like I want the first one plus the second one times 4. And so that might help you. Meaning, I probably would do it this way. I would just say, I want this one, and then I want 4 times this one, and then I want 2 times that one, and then I want 4 times this one, and then 2 equals 2 times this one. This just separates your calculation. Excel's good at things like this. And you say, I want to add those up. There's a little symbol to do that. Now again, I have a lot of practice with Excel, as you can tell, but now I have the number that's inside those parentheses. And then I could multiply that times pi over 24, and then multiply by 9800 pi over 3, and then I've got my answer. So there's a little bit of Excel work. If you're doing this in a calculator, you might want to do it in a similar way, meaning compute all the stuff inside of there, and then multiply. There's a challenge here of managing this. But the main thing I want to do is to review the setup, which was you have to think about, for pumping problems, you first label a typical slice at a given height, and you ask yourself 2 questions. How much does that weigh, and how far does it get lifted? And if you've done enough of these, you realize the main thing that changes is the area of the slice. All right, hope that's helpful.